In theory, NASA's impossible engine would allow travel from Earth to the Moon in less than 2 seconds. That means they would be on the Moon by now if they left Earth when you clicked on this video. That does sound impossible, but then again, NASA has always been known to do the impossible. Their helical engine concept is the source of this literal lightspeed travel, but it is also the source of some drama and intellectual arguments because somehow it defies the laws of physics as we know it. Newton's law of motion states that for every action, there's an equal and opposite reaction. For instance, when you jump, you push against the ground, which is your action, and the reaction is the ground lifting you in the air. Same thing happens with the jets pushing against air and the air then reacting by pushing the jet forward. But the helical engine works differently to outrace light. Traveling at the speed of light. Light may seem like it's everywhere at a time, but it's actually not. The light you see is made up of beams moving at very high speeds. So when you travel at the speed of light, or very close to it, these beams would have a hard time keeping up with you. The result? An illusion of space and time warping that would make Star Trek look less like sci-fi. It starts with a warped vision where you see so many things so fast that you end up seeing virtually nothing that isn't moving at the same speed as you. Take one look behind, and it would be darkness behind you because light is still only trying to catch up. In front, however, everything appears brighter and more intense than normal, as light in front of you would arrive quicker. This is because the light was already coming at you at, well, the speed of light, and you were also going to it at the same speed. This is what it would feel like to travel in a space vehicle powered by the helical engine. For many reasons, it remains the closest engine to actualizing lightspeed travel, as current rockets have major setbacks that make it impossible for them to even try. Current rocket setbacks. For today's rockets to move at incredible speeds, they have to be packed with incredible amounts of fuel, which is as uneconomical as it sounds. And with a large part of space exploration based on being able to transport the average person to space, and not just millionaires or billionaires, it would seem almost pointless to go further with the current rockets we have. And that's not the only setback that sets them back, because even if we had enough fuel, there would always be the need for more, because loading rockets with huge amounts of fuel would make them much heavier, and thus they'll need even more fuel for that extra weight. Case study, the Saturn V. NASA's Saturn V burns 20 kilograms of fuel to transport 1 kilogram of payload to the Moon. And the greater the distance, the more fuel required. For the Saturn V to travel to the nearest star, for instance, it would get 100 times more thirsty and require 2,000 kilograms of fuel to transport 1 kilogram of payload. So there is a list of factors that must be addressed if today's rockets are ever to become time-warping vehicles of the future. They must be made of materials that could survive the harshest of conditions, be economical on fuel, and maybe the most important of all, be powered by propulsion systems of the future, such as the helical engine. The helical engine. The helical engine is a reactionless drive engine concept designed by NASA engineer David Bruns. The concept is actually based on a somewhat impossible exploitation of a weird glitch in Einsteinian physics. So, say there's a container in a vacuum, such as space, and this container contains some physical object. Science has shown us that the mass of this physical object would significantly increase when it's accelerated to speeds close to the speed of light. This is where the trick comes in full play, because once this object collides with a wall of the container in the direction in which it was accelerated, it thrusts the container with some force in that direction, ultimately providing thrust. And as a result of that collision, its speed decreases, making its mass decrease, and so a rebounding hit to the opposite wall would not have as much braking force. Then the object is accelerated in the original direction again, providing thrust again, with its rebound hit on the opposite wall having less of an impact, again. When this is done on repeat multiple times in less than a second, the result is a constant thrust that keeps the container moving in the desired direction. For David Bruns' helical engine, the physical object would be a circular particle accelerator where ions are accelerated to light speeds. And packed with enough ions, the helical engine could push anything through space. However, to accommodate the number of ions needed for the helical engine, it would need to be very huge, about 200 meters long and 12 meters wide huge. That's the length of 2 standard football pitches placed side by side. Needless to say, the age of motherships may not be too far away. So, on paper, space vehicles powered by the helical engine could attain light speeds without the exhaust of a propellant, making it super economical compared to conventional engines that burn tons of fuel every minute. For now though, the helical engine still seems decades away from actually becoming a thing. In fact, David Bruns admitted in his paper that some of his calculations could be wrong, but he insists that the concept is valid. Basically, he's putting the idea out there for anyone to take the mantle and make it into a machine that counters the law of action and reaction. And this defiance of the laws of physics is one reason why the helical engine doesn't have the backing of many experts yet. And who can blame them? This isn't the first time a potential new invention dared to counter the laws of physics, and more often than not, the laws of physics come out on top. However, there are some that have put up a lasting fight, particularly the EM drive and the ion drive. Future of propulsion systems. EM drive. The EM drive was invented by Roger Shawyer in 1999. It is a reactionless drive engine that is allegedly designed to work as a microwave resonant cavity thruster. And although thruster seems to come up in EM drive conversations, it doesn't work like the traditional ones because it emits no propellant. That is, nothing shot out of the back to push the payload forward. Yes, it also counters the law of conservation of momentum like the helical engine. And so critics have had their go at the EM drive, with a notable jab coming from Caltech's Jim Woodward, who said the EM drive is synonymous with trying to accelerate a car by getting into the driver's seat and pushing on the windshield. Well, after a series of tests, it has been established that the EM drive does produce some thrust, maybe with a not so impressive thrust to power ratio of 1 millinewton per kilowatt, but it does produce some thrust. The argument remains that not all factors have been considered in the EM drive tests that have been carried out, and that maybe, just maybe, the thrust is coming from some other source, such as magnetic interactions between the wires in use and the Earth's magnetic field, or some electrostatic interaction, or maybe even vibration. Roger Shawyer claims that the thrust is a result of the differential radiation pressure between the two ends of the EM drive. There's still uncertainty as to whether this is true or not, but one thing is certain. The EM drive has a lot to do to prove its credibility beyond any reasonable doubt, even though the concept upon which it is based hasn't exactly been debunked either. Ion drive. After all, the ion drive faced its fair share of skepticism before proving itself to actually be one of the most fuel-efficient of all spacecraft propulsion methods. So much so that in 2016, NASA awarded Aerojet Rocketdyne $67 million to design, build, and test a propulsion system based on the ion drive. It converts solar power to electricity that's used to accelerate ions out of a nozzle, ultimately producing thrust. This thrust is relatively small and doesn't come with too much momentum, so the ion drive wouldn't qualify for high-speed travel just yet. For longer-term missions, though, ion drive engines have proven efficient and cost-effective, and currently power both NASA's Dawn probe and the Lunar Gateway space station. Despite the criticisms, it seems only right to keep working on the ion drive, EM drive, the helical engine, and other futuristic propulsion systems. The reward, if they reach full potential, far outweighs the disappointment that would come with failed tests. Today, without these systems, it's impossible for us to get to any other star, besides the Sun, in less than 50,000 years. And you would agree that that's quite a long time. So NASA has their work cut out, and you also have an important role to play, which is to subscribe to this channel. Hey, it really helps us spread the word around. So kindly smash the red subscribe button down below, and if you're feeling generous, give us a like. Let us know any questions you have in the comments section. We're curious what you think about all of this futuristic tech. that will be all for this video. Thanks for watching.